Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will see the last part of complex numbers and we will see the different forms of a complex number. Let's see the different forms of a complex number. M is a point with affix z, z equals a plus ib. Remember, this is called the algebraic form of z. If r is the modulus of z and theta is an argument of z, then for every non-zero complex number z, we can say that the trigonometric of z is z equals r into cosine theta plus I sine theta, where r is the modulus and theta is an argument. And we can say that the exponential form of z is z equals r ei theta. In fact, these are just different ways to express the complex number by, and we can see that the trigonometric form and the exponential form are so related because both of them are related to r and theta. Now, if I know r, if I know theta, I can write any complex number in either an exponential form or in a trigonometric form. Now, let's see this example. A, B, and C are 3 points with respective affixes. We need to complete this table by writing ZA, ZB, and ZC in trigonometric and exponential forms. This is Z, so remember to write in trigonometric and or exponential form. We need the modulus and an argument. Now we use the calculator. Let's see, we have 3i, this is the calculator, it's in the complex mode, and the angle is in radian. We just write 3i equals, we need r and theta, shift complex, r theta, r is 3 and theta is half pi. So in this case, r is 3, theta is pi over 2. The trigonometric form is 3 into cosine pi over 2 plus I sine pi over 2, and this would be the exponential form. Well, similarly here, r is 2 and theta, because this is negative real, is pi. So the trigonometric form would be in this form, and this would be the exponential form. Now in the last case, using the calculator, the modulus is radical 2, theta is 3 pi over 4, so this is the trigonometric form, and this is the exponential form. Now remember, ei theta is cosine theta plus I sine theta. This is related to the trigonometric form, and this is related to the exponential form. Now we need to write each of the complex numbers below in algebraic form. This is Z1. We can do it either using the calculator or algebraically. Let's begin. If we write it as cosine pi plus I sine pi, we know that cosine pi is negative 1 and sine pi is 0, so we get negative 1. Now, how do we do it using the calculator? We're going to see it after a while. This is part B. We also translate the exponential into trigonometric. You can use the calculator for these values, and we get negative 1. And then in this case, this is I, and in the fourth case, we get minus I. Part E, this is e to the power 0, which is 1. And this case, 2 pi is the same as 0. Remember, it's one complete rotation. Now, how do we do it using the calculator? Let's see. This is the calculator. Let's say I want to write this form using the calculator. I don't use the exponential, which is used here in the calculator, because we are now in the complex form. Remember, the calculator is in the complex mode and the angle is in radian. How do I write such an expression? I write r theta. R in this case is 1, and then I have to write this symbol, which is shift minus. You see this symbol here, this small symbol that looks like less than. This is what we use, and then the angle is pi. This is pi. So by now r, this symbol, and then theta, this is equal to negative 1, and this is what we get. For example, if I want to write part D using the calculator, so this is AC1 and then this symbol and then negative pi over 2, this is equal to negative I. Okay, now let's continue with this application. A, B, and C are 3 points such that this is what we have. The first question asks to write ZA in exponential and algebraic forms and then to find the coordinates of A. Remember here A is given in trigonometric form. Try to do it alone. Well, this is very easy. It's very easy to go on from the trigonometric form onto the exponential form because r is 2 and theta is negative pi over 3. This is what we have. Then we use the calculator to write it in algebraic form, and these are the coordinates. Now we need to write that B in trigonometric and algebraic forms, and it's given in exponential form, and we also need the coordinates of point B. Try also to do it alone and try to use the calculator. Well, this is that B in exponential form, r is 6, theta is 5 pi over 6, so it's very easy to write the trigonometric form, r cosine theta plus I sine theta, and then we use the calculator to get this algebraic form, and the coordinates would be given as follows. Now write ZC in algebraic, exponential, and trigonometric forms, and it's given here geometrically. Let's see. So from the geometric form onto the algebraic form, it's very easy. We just write it as A plus IB. Then we use the calculator to write it in exponential form and the trigonometric form. Now let's see the second application. We need to complete the table by filling in the missing number in the required form. Now here try to use the calculator, and the first cell appears in each row would be the given, and you have to find the 3 other forms. Well, here you see this blue line. I like to put this blue line because I can always find the algebraic and or geometric form from one another without the usage of a calculator. And similarly for trigonometric and exponential, we can tell the exponential form directly using the trigonometric form and vice versa. Whereas the problem appears if we want to go from algebraic geometric onto trigonometric exponential, or from trigonometric exponential onto algebraic geometric. And notice also that 0 doesn't have a trigonometric form and it doesn't have an exponential form because both of them are related to the argument theta, and in fact a 0 complex number doesn't have any argument. Let's see this application. We're going to go back to something we've seen before. Well, we need to write each number below in trigonometric and exponential forms. Remember, the trigonometric form is r into cosine theta plus I sine theta. So we have to look at the trigonometric circle in order to remove this minus. Try to remember it. Well, this is what we have. This is the trigonometric form. Consequently, this would be the exponential form. Try to do the second case. Remember, translate the sine into a cosine and the cosine into a sine. And you have a minus here. So first we get rid of this minus by putting inside the brackets. Then We translate the sine onto a cosine and the cosine onto a sine by adding pi over 2 minus alpha, and then we go back to the trigonometric circuit to get the answer. This is the trigonometric form, and this is the exponential form. And remember, 3 pi over 2 and minus pi over 2 are equivalent. This case, ei alpha is cosine alpha plus I sine alpha, and this is what we get. Now this case, well, here you must pay attention that -4 is not r, because r is a modulus and it should always be positive. That's why we have to get rid of this minus. We put it inside and then we try to manage it trigonometrically to get this answer. Okay, let's see some of the properties of the exponential form. They are easy properties, you know them from before. In order to find z prime, we multiply the modulus by the modulus and we add the two arguments because of the properties of powers. We have the same base, we add the powers. Similarly here, in the case of division, we divide the modulus by the modulus, but we subtract the arguments. And here, if Zn, this is Zn in exponential form, we distribute this exponent, we get Rn and e to the power I n theta. And finally, what is Re minus I theta? It's the same as R over E I theta. These are the properties that you know from before. Well, let's see this example. We need to write it in terms of EI alpha. This is what we have. So to remove this minus, we put it in the denominator, and this is what we get. Pay attention to the question. We need to write it in terms of EI alpha. Let's see this case. In this case, if we distribute the exponent and then we divide the exponential into two parts, EI pi is -1 and this is EI alpha. How do we find EI pi? We can use the calculator or we can memorize it. Let's see this case. Well, if we also expand the exponent, this is what we get. And then e pi over 2i, this is a complex number that can be calculated using the calculator. EI pi over 2 is the same as I. Now the last case, if we also expand the exponent, this is what we get. Then e minus pi over 2i is minus I. And to get rid of this minus, we put it in the denominator. Now this application verifies that this quantity is a negative real number. In fact, the exponential form is usually used when we have very big numbers. So write 1 minus I in exponential form, try to use the properties, and then try to simplify in order to get the negative real number. Do it alone. Well, 1 minus I, if we write it exponentially, this is what we get. And 1 minus I 2020 is the exponential form 2020. Then we distribute the exponent for the radical and for e. We get radical 2 to the power 2020 times e to the power negative pi over 4i to the power 2020. The first one gives 2 to the power 1010 if we remove the radical, and here if we multiply this number by that one, this is what we get. And in fact, 2020 over 4 is 505 pi. So this is an odd number of pi's. We remove all the even parts to get pi, and e to the power minus pi I is -1, and this is what we get, which is a negative real number. Now let's see this application. We have complex number z such that z is 2 plus ei theta, where theta falls in this interval. The question is find the set of points M. Try to think about it. Well, this is z. If we subtract 2 from both sides, this is what we get. And now pay attention, the modulus of this complex number is equal to the modulus of EI theta, which is 1. So Zm minus Za is 1, where Za is 2. So Am is 1, and this means that M moves on the circle with center A and radius 1. Now Rima or Amir, let's see, we have a complex number Z, which is 2 plus EI theta. We need to find the modulus of Z in terms of theta. Rima, this is the modulus. She distributed the modulus on 2 and on EI theta. She got the modulus of 2 is 2, the modulus of EI theta is 1, which is 3. Whereas Amir wrote EI theta as cosine theta plus I sine theta. Then he used the property of the modulus, which is the square root of A squared plus B squared. He expanded, this is what he got. Remember, cosine squared plus sine squared is 1. 1 plus 1 is 2, and this is the answer. I think Amir's method is correct, Rima's method is not correct. Pay attention, in case we have a plus here, we cannot distribute the modulus.